People, stop everything. Brand new images of 3i Atlas just dropped, and they completely reshape the entire board. Yes, completely. You're about to see or hear a sequence of evidence that breaks the simplest explanation. It's just another comet. It isn't. It hasn't been. The photos were captured by different observers between November 16th and 17, 2025, from Canada's NEOSat to amateur records from New Mexico to recent images from Puerto Rico. They all show the same point. Atlas remains intact and displays jet structures that do not behave like conventional cometary jets. Here's the hook. An intense forward-facing jet with a reddish hue is present in several images, while at the same time, traditional jets point backward. How can a natural object produce such selective color and orientation? And how does it maintain structural coherence, even though these jets, according to the physics we know, should have torn it apart? The answer, or rather the questions, are far bigger than you think. Let's be practical. The images surfacing this past week show three striking features: a jet facing the observer forward with a reddish tint, several receding jets backward, often symmetrical, and the preservation of the object's core even after perihelion passage. Observers like Satoru Murata from New Mexico, Efrain Morales from Puerto Rico, Rolando Ligustri, and the NEOSat collections agree. There is no visible fragmentation, meaning that quick argument, "oh, the jets are from fragmentation," loses strength because the object seems whole. There was also a curious behavior in the colors. When brightness levels and saturation are adjusted, the forward-facing jet highlights in red and magenta tones, while the traditional tail leans toward greenish and bluish tones. This isn't an aesthetic detail. It's a clue about chemical or physical differences between emissions in opposite directions. How would a single natural body choose different colors depending on jet direction? Does that make sense for known comets? It doesn't. The mass flow problem. Here's the part that makes specialists swallow hard. When you try to calculate the mass flow needed to power these jets, the numbers become extremely uncomfortable for a simple explanation based on ice sublimation. Imagine this. To sustain jets stretching millions of kilometers in opposite directions with a typical gas outflow speed comparable to local sound speed, you'd need an enormous mass flow. In simple terms, it would require material on the order of billions of tons over weeks. To sublimate carbon dioxide at that scale during perihelion, the required energy hits the realm of 16 to 18 digits, an amount that the star at the center of our system at that distance would not plausibly deliver to a nucleus of the size estimated by high-resolution images. Put another way, for Atlas to expel all that mass solely through solar heating, it would need to absorb energy over an area equivalent to thousands of square kilometers, far larger than the projected area for a nucleus with the diameter estimated by telescopes like Hubble. Replace carbon dioxide with water, and the numbers get even worse. The required area skyrockets, and there's more. The jets appear collimated, highly directional, and maintain orientation over long distances despite the object's measured rotation. That breaks the intuition that simple rotating ice pockets should spew material randomly. 3. Explanatory paths. Given this scenario, 3 explanatory paths emerge and deserve serious exploration. 1. Exotic cometary object, still possible with caveats. The conservative explanation admits that physics and chemistry in distant regions of the universe might produce behaviors unknown to us. Maybe certain porosities or thermal regimes generate narrow color-selective jets. But for this hypothesis to hold, it must account for both mass scale and structural integrity, something that currently demands energy counts that are hard to justify. 2. Technological object, bold and scientific. Avi Loeb and others argue for seriously considering the hypothesis that some features resemble technological signatures. Directed propulsion. Materials similar to industrial alloys, non-cometary mass behavior, and non-gravitational accelerations consistent with engineered jets. This is not a declaration of it's alien, it's an exploratory hypothesis. If there are signs consistent with technology, we must test them with instruments, samples, and missions, exactly as we would if we suspected an artificial, human-built artifact. 3. Plasmatic life or plasmatic organism, radical but coherent, A completely different proposal suggests Atlas could be a plasma-based life form, a self-organized system capable of interacting with electromagnetic fields, moving, and even altering its appearance. Research on plasma structures in Earth's thermosphere and theoretical studies describe self-illuminated cores, accelerations, and clustering reminiscent of biological behavior without carbon as we know it. This redefines the concept of life and demands reopening astrobiological vocabulary. All hypotheses have conceptual costs. Honest science does not discard any of them out of prejudice. It tests them with rigorous data. What the data demands. If we want to move forward without dogma, here are concrete immediate steps. High-resolution imaging. Waiting for higher detail images, for example, from spacecraft cameras or high-resolution telescopes, is a priority. Successive images can close or open hypotheses. Targeted spectrometry, measuring chemical composition precisely. Nickel without iron or anomalous metal proportions is a clue that needs independent confirmation. Dynamic monitoring, tracking jet orientation over time to correlate with the object's rotation. If jets remain fixed relative to space instead of rotating with the nucleus, the implications are significant. Sampling missions. If technically and financially feasible, sending a probe to collect material could be decisive. In situ sampling would break or validate hypotheses. Interdisciplinary channels, plasma physics, astrobiology, aerospace engineering, and planetary science must work together quickly. These aren't abstract suggestions. These are actionable steps that could be implemented within months if the will and funding exist. The 12 anomalies still without explanation. Before moving forward, here are the 12 points that remain outside any ordinary explanation. Memorize them, share them, and demand clear answers. 1. A retrograde trajectory perfectly aligned with the ecliptic plane, something nearly impossible for interstellar objects. Most objects entering our solar system from interstellar space arrive at random angles. Atlas moves backward relative to planetary motion, yet stays perfectly aligned with the ecliptic plane, the flat disk where planets orbit. The statistical probability of this happening by chance is extremely low. 2. Jets directed toward the star at the center of our system, producing an anti-tail not attributable to viewing angle alone. Normal comets have tails blown away from the sun by solar wind and radiation pressure. Atlas has jets pointing toward the sun. This is not a perspective trick. Multiple observers from different locations confirm the same phenomenon. 3. A nucleus with mass far above expectations for interstellar travelers moving at high speed. Atlas is significantly more massive than Oumuamua or 2I Borisov, yet it maintains interstellar velocities. For a natural object, this combination is difficult to reconcile with known formation mechanisms. 4. An arrival timing that allowed close passes by Mars, Venus, and Jupiter, improbable without extreme coincidence. The trajectory brought Atlas near multiple planets at times that would maximize observational opportunities and gravitational interactions. If this were planned, it would be brilliant. If it's coincidence, it's remarkable. 5. A plume rich in nickel with levels far above typical comets and solar system bodies. Spectroscopic analysis revealed nickel signatures at concentrations that don't match any known cometary composition. Nickel is typically locked in metallic cores of differentiated bodies, not in icy comets. 6. Gas emission with almost no water, roughly 4% water content, unusual for comet standards. Water ice is the primary volatile in most comets. Atlas has almost none. This alone places it in a category of extreme outliers. 7. Strongly negative optical polarization, never recorded in known natural objects. When light reflects off Atlas, it shows polarization characteristics that have never been observed in any comet, asteroid, or natural solar system body. This suggests the surface material or surrounding particles have unique optical properties. 8. Apparent origin near the same sky region as the WOW signal, a coincidence striking even to skeptics. In 1977, the Big Ear radio telescope detected a strong narrowband signal from the direction of Sagittarius. Atlas's trajectory traces back to approximately the same region. Coincidence? Possibly, but it's worth noting. 9. A sudden brightness increase accompanied by a deeper blue hue than the reference star. As Atlas approached perihelion, it didn't just brighten, it changed color in ways inconsistent with thermal models of cometary outgassing. The blue shift suggests a different emission mechanism. 10. Jets requiring an absorption area incompatible with the estimated nucleus size, suggesting major energy discrepancy. The energy needed to produce the observed jets would require a surface area absorbing solar radiation far larger than the nucleus diameter, estimated from high-resolution imaging. Where is this energy coming from? 11. Non-gravitational acceleration, indicating loss of about 13% of its mass without a visible cloud to justify the ejection. Atlas is accelerating in ways that suggest massive outgassing, yet we don't see the expected debris cloud or coma expansion. The mass is disappearing without a trace. 12. Extremely collimated jets maintaining direction across millions of kilometers, ignoring the expected rotation of such bodies. Even as Atlas rotates with a period of approximately 16 hours, the jets remain tightly focused and directional. Natural outgassing from rotating ice pockets should create spiral patterns. Atlas doesn't do this. Each anomaly is serious on its own. Together, they form a set of questions that simply does not fit conventional models and demands rigorous, transparent, verifiable investigation. The color mystery. Let's focus on one of the most visually striking anomalies: the color differentiation in the jets. When astrophotographers process the raw images and adjust for brightness and saturation, something remarkable appears. The forward-facing jet, the one pointing toward the sun, glows with red and magenta tones. The backward jets and traditional tail show greenish and bluish hues. Why does this matter? Because color in astronomical objects tells us about composition and temperature. Different molecules emit light at different wavelengths. Dust particles of different sizes scatter light differently. For a single object to produce jets of distinctly different colors in opposite directions suggests one of several possibilities. Different chemical compositions being ejected from different locations on the surface, different particle sizes in different jets, different temperatures or ionization states, or different physical processes entirely, one natural, one not. If the forward jet is hotter or contains different materials than the backward jets, we need to explain why. Comets don't typically have regional chemical variations strong enough to produce such stark color differences. They're relatively homogeneous mixtures of ice and dust, unless Atlas isn't a typical comet. Unless it's differentiated, meaning it has distinct layers or regions of different composition, like a planet or asteroid, but differentiated bodies don't produce massive jets. They're solid. The color mystery deepens the puzzle and adds weight to the hypothesis that Atlas is not what it appears to be. The rotation paradox. Now let's talk about rotation. Measurements suggest Atlas rotates with a period of approximately 16 hours. This is relatively slow for a small body, but not unprecedented. Here's the problem. If Atlas is a rotating nucleus with active regions, pockets of volatile ice that sublimate when exposed to sunlight, we should see the jets rotate with the nucleus. As the active regions turn into and out of sunlight, the jets should appear, disappear, and sweep across space like a rotating sprinkler. This creates what astronomers call a spiral structure in the coma and tail. We see this in many comets. It's a natural consequence of rotation plus outgassing. Atlas doesn't do this. The jets remain stable, collimated, and directional over long periods. They don't spiral, they don't sweep. They point in consistent directions despite the rotation. How is this possible? One explanation is that the jets aren't tied to surface features. They're somehow decoupled from the rotation. But how? What mechanism allows jets to maintain orientation independent of the body producing them? Another explanation is that the jets aren't produced by passive sublimation. They're actively controlled or directed by some mechanism that compensates for rotation. This sounds like propulsion. This sounds like technology. Or, if we entertain the plasma hypothesis, the jets could be electromagnetic structures that organize themselves in response to the solar wind and interplanetary magnetic field, maintaining orientation relative to external fields rather than the rotating nucleus. Any of these explanations takes us far from conventional cometary physics. The fragmentation that didn't happen. One of the most telling observations is what didn't happen. Atlas passed through perihelion, its closest approach to the Sun, and survived intact. Perihelion is the moment of maximum stress for a comet. Solar heating is at its peak. Thermal gradients create mechanical stress. Volatile ices sublimate rapidly, creating internal pressure. Many comets fragment at perihelion, some disintegrate entirely. Given the intensity of the jets and the apparent mass loss, Atlas should have been under enormous stress. The jets themselves, if produced by natural outgassing, would create torques and forces that could tear a weakly bound rubble pile apart. Yet Atlas emerged from perihelion intact. No fragmentation, no breakup. The nucleus remains coherent. This suggests one of two things. Either Atlas is far more structurally robust than a typical comet, perhaps a solid monolithic body rather than a rubble pile, or the jets aren't producing the mechanical stresses we think they are. If Atlas is a solid body, it's not a typical comet. Science advances by exhausting conventional explanations before invoking extraordinary ones. Others are more open to unconventional hypotheses. Avi Loeb, the Harvard astronomer who proposed that Oumuamua might be artificial, has suggested that Atlas deserves serious investigation as a potential technological object. He's called for dedicated observation campaigns and even proposed sending a probe to intercept it. A smaller group of researchers is exploring the plasma hypothesis. This is more speculative and less mainstream, but it's based on legitimate physics. Plasma structures can self-organize, maintain coherence, and interact with electromagnetic fields in complex ways. If life can emerge from chemistry, why not from plasma physics? The challenge is that most astronomers are trained to think in terms of rocks and ice. Expanding the conceptual framework to include technology or plasma-based phenomena requires a shift in perspective that many find uncomfortable. But discomfort isn't a reason to dismiss evidence. If the data points towards something unconventional, we have a responsibility to follow where it leads. The transparency problem. One of the most frustrating aspects of the Atlas situation is the lack of transparency from some official channels. Amateur astronomers around the world are capturing stunning images and sharing them openly. Within hours of observation, processed images appear on forums, social media, and astronomy websites. The amateur community is doing incredible work and making it freely available. Meanwhile, some professional observatories and space agencies have been slower to release data. There are reports of high-resolution images that haven't been made public, spectroscopic data that's been collected but not published, observations that are mentioned in passing but not detailed. Why the delay? There are legitimate reasons. Professional astronomers need time to analyze data, write papers, and go through peer review. Releasing raw data without context can lead to misinterpretation. But there's a fine line between careful analysis and gatekeeping. When amateur observers are producing better publicly available images than professional institutions, something is wrong. The public has a right to know what's being observed. If Atlas represents something truly anomalous, it's a discovery that belongs to humanity, not to a select group of researchers or institutions. Transparency builds trust. Secrecy breeds suspicion. If there's nothing to hide, then release the data. Let the global scientific community analyze it. Let the public see what's happening in their solar system. What happens next? So where do we go from here? Atlas is moving away from the sun now, heading back toward interstellar space. We have a limited window to gather more data before it becomes too faint to observe. The next few weeks are critical. Every observation counts. Every spectrum, every image, every measurement adds to our understanding. Here's what needs to happen. First, coordinated observation campaigns. Multiple telescopes, multiple wavelengths, multiple locations. We need to build a comprehensive data set that can be analyzed from every angle. Second, spectroscopic follow-up. We need detailed composition analysis. What molecules are present? What's the isotopic ratio? Are there any signatures that don't fit natural solar system material? Third, astrometric precision. We need to track Atlas's trajectory with extreme accuracy. Any deviations from a purely gravitational path would be significant. Non-gravitational acceleration is one of the strongest pieces of evidence for something unusual. Fourth, modeling and simulation. We need to test whether any natural mechanism can reproduce the observed behavior. If we can't build a plausible natural model, that strengthens the case for unconventional explanations. Fifth, And most ambitiously, we should consider a probe mission. If Atlas is still within reach, sending a spacecraft to intercept it could provide definitive answers. We've done this before with comets. We can do it again. The technology exists. The question is whether we have the will and the funding to make it happen. The bigger picture. Let's zoom out for a moment and consider what Atlas means in the bigger picture of astronomy and our place in the universe. For decades, we've searched for signs of extraterrestrial intelligence. We've built radio telescopes, scanned the skies for signals, and sent messages into space. We've found nothing definitive. But maybe we've been looking in the wrong way. Maybe intelligence doesn't announce itself with radio broadcasts. Maybe it travels silently through space, observing, collecting data, moving on. If Atlas is a probe, and that's still a big if, it would represent a fundamentally different approach to exploring the galaxy, not sending signals and waiting for responses, but sending physical objects that can observe directly. This makes sense from an engineering perspective. Radio signals degrade over distance. Physical probes can carry sophisticated instruments and operate for long periods. If you want to study a solar system, sending a probe is more effective than sending a signal. And if you're an advanced civilization, you might send thousands or millions of probes, seeding the galaxy with observers. Most would go unnoticed, but occasionally one would pass through a system with intelligent life capable of detecting it. Maybe that's what we're seeing. Maybe Atlas is one of those probes, and we're finally advanced enough to notice. Or maybe it's something even stranger, a plasma-based life form that evolved in the interstellar medium, a natural phenomenon we've never encountered before, an exotic comet that pushes the boundaries of what we thought possible. Any of these answers would be profound. Any of them would change how we see the universe. Folks, here's where we stand. The new images of 3I Atlas show an object that does not behave like any comet we've studied before. The jets are too collimated, the colors are too different, the structural integrity is too strong, the energy requirements are too high, the trajectory is too convenient, the composition is too unusual. We have three main hypotheses on the table: an exotic natural comet with properties we've never seen before, a technological artifact, possibly a probe from another civilization, or a plasma-based entity that represents a form of life we've never imagined. None of these hypotheses is proven. All of them deserve serious investigation. What we know for certain is that Atlas is anomalous. Multiple independent observers have documented behaviors that don't fit conventional models. The data is real, the anomalies are real, the questions are real. What we do next matters. If we dismiss this as just another comet without proper investigation, we might miss the most important discovery in human history. If we jump to conclusions without sufficient evidence, we undermine the credibility of science. The right path is rigorous investigation with an open mind. Test every hypothesis, gather every piece of data, follow the evidence wherever it leads, and demand transparency. This isn't a discovery for a select few. This is a discovery for all of humanity. We have a right to know what's traveling through our solar system. Now I want to hear from you. Which of the 12 anomalies do you find most compelling? Which hypothesis makes the most sense? And what do you think should be done next? Leave your thoughts in the comments. I read every single one. Subscribe to the channel and hit the notification bell because we're going to be covering every development as it happens. The next few weeks could change everything we know about what's out there. And if you want to go even deeper into the Atlas mystery, click on the video appearing on your screen right now, where we break down the plasma hypothesis in detail and explain how it could work. I'll see you there.